Whenever I do computer builds, I like to test things as I move along instead of putting everything into the case and then throwing through the switch for the first time. So with that end, the minimum that we can do testing typically is a motherboard, a CPU and its cooler, and the RAM. So with this far into the build, I'm going to go ahead and try this out and see if this is functional. That way, if there is a problem, I have less parts to debug. Now, to power it up, I'm using this power supply. So this power supply is the Seasonic TX1600. In a nutshell, this is basically top of the line specs. So in terms of wattage, 1600 watts. In terms of efficiency, 80 plus titanium. In terms of specs, it is ATX 3.1 and PCA 5.1 ready. And even in terms of the warranty, 12-year warranty in that, all from a company that's well respected, Seasonic, in terms of building power supplies. In fact, they often build power supplies for other OEM companies. Now, I will admit most people are not going to need this kind of power supply. You won't need 1600 watts. The reason why I went with 1600 watts is because I want to leave the door open for potentially having multiple GPUs in this server. And if we're today's modern GPUs using potentially up to 600 watts, it can quickly add up in terms of a high amount of wattage. Now, I should also say that Seasonic makes another 1600 watt power supply, which is the PC or the PX 1600. And really the only difference between this one, the TX 1600, and the PX 1600 is the efficiency, titanium versus platinum, which is only a slight difference in efficiency. I believe 94% versus 92%. So again, most people probably won't need the extra level efficiency. But when I went to buy the parts, the PX 1600 wasn't available at the time. So I went ahead and moved up to the TX just so I can have what I need to do my build. Now the PSU itself comes with power supply tester. So before we connect it to the motherboard, let's try it out on the tester. That's this box right here. This box actually serves two different purposes. One is, it's like I said, a tester, but it also can act as a 90-degree adapter for the 24 pin on the motherboard. So we can attach it here. This attaches to the motherboard and the cable would go in this way instead of the typical this way into the motherboard. And that could help with airflow. So now I'm going to turn on the switch. You can see there's a red light on here. If I press this button, the blue light indicates that everything is working good in the power supply. So now we're ready to move on to trying it with the motherboard itself. I have here everything ready to do that test. Basically what I've done is connected three power wires from our power supply to our motherboard. It's the 24-pin connection and the two 8-pin CPU. I have a very simple keyboard connected to a USB dongle on the side of the motherboard so that I can do input into it. And I have an HDMI cable connected to my monitor so I can see it power on. So with that, let's go ahead and turn it on. Now, we do have one complication. This motherboard doesn't include any power switch. And I don't have anything connected to the front panel connector to give me that power switch in there. So what I'm going to do instead is I'm going to use the screwdriver to actually short the two pins that come out on the top that you can see on your screen. That is the actual power, and that's all the button does, is when you press it on the front, it just momentarily connects those two pins. So I'm going to connect it using the screwdriver, and when I see a power on, I will release the two pins. So the first thing we need to do is turn on the power on the back side of the power supply, and now let's go ahead and give it a try to turn it on. Now it's powering up. I see the fans moving here. We had momentarily a red light, then yellow, and went to the green. We can see the ASUS banner come up on the screen, and then finally we have our BIOS, which looks pretty good. And in the BIOS here, we can verify a few things. So the first thing that catches my eye right off the bat is the amount of memory and the CPU type, which are both correct. The speed on it is less than our 6400 megahertz speed, but that's okay. We haven't enabled any of the XMP mode in that. The next thing that catches my eye is the temperature, which looks pretty good at 25 degrees Celsius. Our fan, we can see confirmation that our fans are running, which is good. What I'm going to do next is, I'm not really going to set up or change the BIOS too much, but what I will do is go ahead and upgrade the BIOS to the latest released version. So I have a USB stick here with the latest version in it. I will plug that into one of the ports on the back. We can then go into the advanced mode by using our mouse. Let's see, we're looking for the Easy BIOS Flash routine, I believe it's tool. You can see right here, confirmation, this is the latest BIOS. The nice thing is this the ASUS Easy Flash utility actually supports a zip file, so that makes it convenient. All we have to do is just download it and just place it on a USB stick. So let's go ahead and update with that. Don't have any BitLocker. Now we can see the utility doing its thing and updating it. Now while it's running, one thing we'll say is this is the reason why I like buying CPUs that have built-in graphics cards in them. So I can do this minimal testing without even adding a GPU to it. And I feel, by trying to keep the parts to an absolute minimum, if I do run into any sort of issues, then it's easier to debug which problem it might be. I can see the new BIOS revision at the top. Says 1401. I believe previously it was 02 something. So let's go into the BIOS by pressing F1. And again, we can see the new BIOS version over here. Okay, I think we can call this a good test in that, we now have the confidence that we have basic functionality from the board, the CPU, and the RAM. So that means when we go on to build the rest of the system, we don't have to worry about at least these core parts working in that. And if there is another part that isn't working, knowing that these are functional will make it easier to figure out those kind of issues in that. So let's move on to the next part of the build. Let's next talk about the hard drives I'll be putting in the case. So I said earlier that the motherboard have 5 M.2 slots in that, 1 PCIe 5 and 1 PCIe 4 that are connected to the CPU, 3 PCIe 4 that are connected to the chipset, and in addition we have 4 SATA drives that are also connected to the chipset. And when you're considering what kind of drives to place in your system, you need to take into account first the speed. You'll have the lowest latency or the fastest speed by you taking advantage of the slots that are connected directly to the CPU as versus going through the chipset. However, if you're going to want to do a RAID or a mirror or redundancy, then you need to often put those drives on similar connections. It wouldn't make much sense to have one connection on PCIe 5 and one on 4 because the speed would be brought down to the slowest drive. Or the same could be said about connecting one that goes directly to the CPU and another one that goes to the chipset. So you need to take these into account. Then finally, in some motherboards in that they have PCIe lane sharing. In this particular motherboard, one of the M.2 slots actually shares its PCIe lanes with the SATA drive connections. So what that means is that one needs to choose which they want to use, the SATA connections or the M.2 slot. So in my particular build, I plan on, as I said, to do Linux server with Proxmox on it. Now, the Proxmox operating system doesn't necessarily need to be high performance in that, but I would like to have some redundancy on it, such that one attribute I like to have is if I have any drive failure in my system, then I can still log into the machine and figure out what the issue is and repair that. So with that said, I plan on putting the operating system on 2 SATA drives. These are 2 Samsung 870 EVOs. They're 500 megabytes in size, probably more than I need, but the price was cheap enough, so I just went with the 500 megabytes. And I'll set them up as a mirror such that if one of them fails, the other one can take over and we can still log into the operating system and look at the rest of the machine. And as far as the M.2 slots, I'm actually going to use 2 of them. In the fastest slot, which is the PCIe 5 that connects directly to the CPU, I'm going to place this crucial T705 M.2 drive. This is a 2 terabyte drive. And most likely what I'll end up using for this one is to use for the storage of all the virtual machines on the Proxmox server. And then for the other slot that's connected directly to the CPU, the PCIe 4, I'm going to use this Samsung 990 Pro. This is a 4 terabyte drive. And that way, if I have any really large data sets or other kind of large space needs in that, I'll have this second drive that I can use. Now, redundancy on those last 2 is not a big deal for me because I'm going to have a separate NAS on my network eventually that I can back up all my data to and that. And I can tolerate some downtime if one of those drives were to fail to restore from a backup and then go from there. So like we did minimal testing before on the motherboard, the CPU, and the RAM, let's go ahead and install our drives now and do the testing while it's outside of the case. That way if there's any problems, it's easy to get at them and replace them. So I'm going to start with the PCIe 5 slot, which is this one right here connected to the CPU. But before that, let's go ahead and remove the protective plastic from the motherboard. So they got one here covering this large heatsink. And there's also a couple little ones here covering the ASUS logo on those buttons. ASUS made this really easy. These are toolless connections and that, so all we have to do is press this button on this side and you can see the heatsink simply comes right off from the top. And then down below for the connection, there's a slider here that you can choose how long your M.2 is. Now, my particular M.2, this crucial T705 that we're going to be placing here, is just the normal length. So what I need to first do is slide this back out of the way, and then we have to remove this protective tape over the top of the thermal pads, so that way you can get some cooling on it. Now the drive itself has labels on it, but in this case the labels are safe to use on the drive itself. So we're looking at the notch on the front and matching it to the slot here. We can slide it in, push down, and then slide that back right onto it. And then in terms of putting the heatsink back on the top, we just remove once again the label that's on over the thermal pad, and we can simply just push it in and click it down. All right, next let's go ahead and install the second M.2 drive, which is in the PCIe 4. So this is under this plate. Now this plate is similar where we have a button here to press, except now the entire heatsink is on a hinge, which is kind of interesting. Makes it very easy to open up. And it's a similar kind of story where we need to connect this, which is our Samsung 990 Pro, into the connection into the slot right here, because this is the PCIe 4 slot connected to the CPU. And so we're just going to slide that into its slot, hold it down, and this connection right here looks like it's just a quick connect. So it's just that when you push it down, it snaps in place. If I want to release it, I just press this here and it would just pop right up. So we have to remove the thermal pad label again for the one drive we're going to be using, as so. And then we can simply close and lock this one in place. And finally, let's connect our two SATA drives. These are our 2.5-inch Samsung 870 EVOs. We're going to plug them in over here. We'll use the two cables that come with the motherboard. So I'll simply just connect them in to the connectors on the side here. So one there and one. I'll just simply use the 2 ports. I'm not sure if those will ultimately be the ports I'll use, but we'll just use that for testing purposes. And then we connect our cable to our drive. There's one. And there's our second one. Keep them off to the side, and then I have on my power supply SATA cable and that, so we need to connect those also to the drive. Okay, now let's power it on and see and confirm if all these drives are working. I'm going to power on using the same screwdriver trick that we used before. I should note that all the installation I did of the drives is with the power supply off and unplugged. That way we didn't risk anything there. So let's go ahead and turn it on. And hopefully we'll see all our drives in the BIOS screen. Let's take a look and see what we got. We have our 2 SATA drives showing up, very nice, 500 gigabytes each. And we have our 2 M.2, our 2 megabytes in the first slot, and our 2 terabytes in our first slot, and 4 terabytes in our second slot. So once again, I'm not going to do any more setup than just confirm that this is working. So now we have the confidence that those parts are okay, and we can move on to the next part of the build. So the next step to go in our build is actually put the motherboard back into the case itself. So let's go ahead and do that. Oh, before I do that, I do need to take the plastic off the back of the motherboard here. Now this is going to be a little bit tricky in terms of trying to get the screw in here without the motherboard itself moving all around, but let's have a go at it. Okay, first screw in, that's always the hardest one. So now let's get a second one in, and then the rest should go in pretty easy. Very nice. Now we should be able to tip it up and do the rest of the screws. There's a total of 5 that holds the motherboard in. Okay, we can place the case back down and we can continue on adding more things inside it. Starting to get a little heavier. Let's next add the power supply to the side here. So it would go orientation. So I'm going to have the fan part of the power supply facing the inside of the case. That way the airflow can go right out here. And also Since this is such a large power supply and the length is so long, I'm going to go ahead and remove this extra drive cage on the side since I'm not really using it anyway, and that'll give me more room for cabling. So that particular drive cage is easily removed by removing the screws on the side here. And then once the 4 screws have been removed, we can slide the cage right on out. As simply as that. Now we can add the power supply to the back, and I'm going to use the screws that actually came with the power supply to attach it as opposed to the case. That way I have better confidence that the screws are compatible with the power supply itself. Ready for the next step. Now I tip the case up on its side so we can have a look at the drive placement, and that, in particular the 2.5 inch SSD drives. The case, as I said, has several locations where we can install hard drives in that. One of them was this extra cage that we just removed. This can be used to hold 3.5 inch hard drives, or the SFX redundant power supply could have gone into here. But we're not going to be using that in the build. I'm going to be placing the drives down here in these trays, but you can see there are also some more trays, 2 more on this side over here, and as I said, the hold down, the graphics hold down bar can actually accommodate 3 more 2.5 inch SSD drives or 2 3.5 inch drives. So in order to place them in here, conveniently they're in these little trays. So we can simply grab the thumb screw on the tray, remove it out of the case, and then we can screw our SSDs to it and then slide it and put it back into place. Now for the screws that we use to attach the SSDs to the tray, there were actually 2 different bags that came with the case. One case said for 3.5 inch hard drive, and one said for card holder bar. It's the card holder bar is the one we actually want. These 3.5 inch hard drive screws, they're the wrong type of thread, so don't use those on a 2.5 inch SSD or you might strip them. Okay, all 4 screws are on. Our drive is on the tray. So now we can simply slide it back into the case here and lock it down. Secure. I have to say, I'm really liking some of the features inside this case. I can see there's a lot of thought and engineering that went into it, and it's pretty high quality as well. Before I put the second drive back in, one of the things I just noticed and I wanted to mention here is that this bracket that's holding this drive actually has an air gap between the metal and the drive itself, if I hold it up to the camera here. And that's kind of nice in that, and when the fan and the air is going through the case, it can actually go on both sides of the drive and be very effective in cooling. And speaking of airflow, let's now address the fan part of our build. Now the case itself comes with a 140 millimeter fan, exhaust fan in the back, and it also comes with a cage that has 2 80 millimeter fans that can be optionally added behind the graphics card that also could be as an exhaust. On the front of the case though, it doesn't come with any fans on that, so we need to add some fans. And the fans I'm going to use is the Noctura A12 by 25. This is really sort of the gold standard when it comes to 120 millimeter fans, and it's pretty well respected. Now the case can hold 3 120 millimeter fans, or 3 of those fans up in front, but it also can hold 3 more inside the case, because remember, this can support 2 360 millimeter radiators, and so the question now really comes, how many fans do we want to install? Now when I do builds, I want to do it with a positive air pressure inside the case. By that I mean there are more fans pushing air into the case than there are exhaust fans taking it out. That way, all these little holes and cracks in the case itself are more likely to have air flowing out than in, so we can control all the air going in from the front coming through the dust filter on the front. And that lets us really keep the server or the inside cleaner with less dust. It won't be no dust, but it'll be minimal dust than if we were letting it just come in anywhere at once. So really, we need to now figure out how many fans we want to put on the front as intake. And by that, let's do some napkin engineering, as I call it. To help us with this napkin engineering, I show the case here, an empty case that we're building in, so we can kind of illustrate the airflow and do some calculations. So let's put some components into the case related to the airflow. The first two would be the back exhaust 140 millimeter, as well as the power supply, because remember the power supply has a fan in it, and that's going to be pulling air from inside the case and exhausting it out to the back. In addition, we have that 280 millimeter drive cage that we can add to the back, and that gives us two more fans that can be used as an exhaust. Now the front, we can have three of the Noctua A12 fans bringing fresh air inside it, as well as an additional three more for a total of six that can be bringing fresh air in. And you can see in the picture there how they might go in. Sort of ignore the radiator. We won't be having a radiator as part of this build. So let's do some calculations. So looking at it from a CFM point of view, I looked up the spec of all the different fans in the case, and I put on the screen the maximum CFMs that could be coming out of that fan. So for the power supply, which is a 135 millimeter fan, it could be up to 120 CFMs according to the specs. The 140 millimeter fan could be 100, and the 280 fans could be 50 each. The Noctua fans, the A12s, are rated at 60 max CFM. Yes, you sort of have to take these CFMs with a grain of salt. I would expect some of these fan ratings, maybe not the Noctua ones themselves, but some of the other ones, to be sort of an ideal lab setting, and in a real setting, the CFM may not be as high. But we would just use this to do the calculation. So adding up all these numbers, if I were to put all these fans in, our exhaust CFM would be a total of 320, and our intake would be a total of 360. So that gives us a positive airflow. So I can be happy with that kind of design. The other thing we got to take into account, as long as we're here doing some napkin engineering, is how to connect the fans up to the motherboard. So to do that, we put the amount of power, or amps, or current, each of the fans could take at maximum. Now the power supply we don't count because it has its own internal power for the fan, so it won't be using the motherboard itself. But the rest of the fans we will be connecting. So the 140 millimeter fan looks to be taking the most at 0.38. Again, this is from the specs. And the rest of the fans are all 0.14. Now, if I were to take all 6 plus 3, all 9 of these fans and connect it to a single connector on the motherboard, that would give us a balanced effect such that as the front gets faster, the back gets faster. So, on the surface, it may seem attractive. But if we do the math on it, the motherboard says the most it can take is 1 amp for a given connector. And if I were to add up all these, we have 1.5 amps. So we can't just simply connect this up to a single connector. Now, what might make logical sense is to connect all the exhaust fans up to one connector and all the intake fans onto another connector. And you can see the math there gives us a number that's under 1 amp, and that's acceptable. But I think what I'm actually going to do is use 4 connectors. I'm going to have the 140 millimeter and the 80 millimeter on separate connectors, and the 3 front fans on one connector and the 3 little further in fans on a separate connector. The reason why I can do that is when I go into the fan control software, I can have a little more flexibility about when I turn on certain fans. For example, I could have the 280 millimeter fans and the additional 3 intake fans be ramped up based on GPU power. whereas the front intake fans and the 140 milliliter exhaust be based more on overall system. And that gives us some capabilities. Now the PSU itself is going to have its own fan curve, but one could sort of assume that that fan is going to be minimal unless it's pulling a lot of power. And if we're pulling a lot of power, most likely it's the GPUs that are loaded. So we can sort of take into account that the power supply fan is going to ramp up with GPU power. Okay, with the decision made that we're going to go with all 6 intake fans in that, which you can see over here, now I'm going to go on to unbox all these and install them. One quick comment in terms of the connection, if you're wondering how it's going to be connected. The exhaust fan, the wire itself will be connected to one port on the motherboard. These two 80 millimeter fans, I have a PWM Y adapter that I'll be using. For the 3 front fans, I've got a triple adapter here that goes down to 1 that I'll be using to connect to one port, and a second one for the next row of 3 fans. For the back fan, it's pretty easy. It's just slots that go on one side and then screw holes down the other. Once it does have a nice rubber grommet here for the wires to come through. So I'm going to push the fan wires through, connect it inside, and then we can tie it down with screws. For the front fans, they actually make it easy to work on that as well. Taking off the front cage we have here, we have this bracket that the fans and or radiator, which I'm not using, which could be used, is attached to. Now to get the bracket out, we have to remove 2 screws, one on each side. And then it's simply move these tabs down and the cage comes right out. And now it makes it very easy to attach our fans. While I'm attaching these fans to the bracket, another thing I want to point out is the orientation of the fan. We want this to be an intake. So we want to make sure that what's pointing towards the front of the fan is where the air goes in. Now a handy way to tell which way the fans are going to be intake versus exhaust is it's very typically when you look on the part that has the label, what would be considered the back of the fan, this is where the air would be coming out, and the air would typically go inside the front of the fan, which tends to be a little more showy in that. Now there are some reverse airflow fans, so that doesn't make it that would break that kind of rule on it and that, but by and large most fans work that way. So we're going to want to make sure this showy part of the fan is facing down in our bracket. When I install the fans on the bracket, I like to keep the screws a little bit loose at first, that way I can sort of fine tune it once I get them all installed. Also notice that I have the wires all facing in the same direction in this particular case on the downside of the bracket, that way I can keep them all nice and neat in terms of wire management. And just like the front bracket, the Silverstone makes it so it's easy to take out the bracket even for the back one, and that it's just held together with 2 screws on each side, which I've already removed, and now we just sort of tilt the bracket and lift it right out of the case, and then we can install the fans across here. Here's our other bracket with the fans all nicely connected. You can see it has a nice scoop where the air comes in. The idea there is when it's in the front of the case, instead of stealing air from the bottom fans, it's actually directing the air more coming in from the top side down in it and into the case, which is kind of clever engineering. Once again, Future Jim here. We've now reached the end of the part 2 of the 3-part build series. On that, when I originally filmed it, I didn't realize the detail was going to make it so long, so I decided to break it up, and I wanted to film sort of an outtake here instead of an abrupt ending. Tune in next time when we're going to see our computer build hero work on the wiring of the case. We're going to introduce the GPU to the case itself, and then finally the testing, the benchmarking of the case itself and that. So I hope to catch you in part 3.